Hello guys, Winston here. A couple weeks ago, Edward Ford got in touch with me and asked if I'd want to help him record a video for the release of the Shapeoko 3. Given that this would be the closest thing to freelance videography that I've ever done, the idea completely terrified me. But it was also an enormous opportunity for me not just to play with the pre-production Shapeoko 3, but to step out of my comfort zone and do something I'd always wanted to try. Film and video production have been one of my hobbies since college. Even though it's not what most people would consider a STEM profession, the techniques and methodologies in cinematography are usually very deliberately chosen. The framing, movement, and editing of shots are designed to elicit a desired response. In this sense, cinematography is, at its core, emotional engineering. Now, one of the tools that filmmakers like to use is a slider. These contraptions, which come in various shapes and sizes, allow you to get very smooth shots. The motion and parallax effects you get from a moving camera are useful to create a three-dimensional awareness of a scene without needing the hands of a surgeon or some other form of magical video stabilization. Now, I'd attempted to make camera sliders before, following instructions on Film Riot and other DIY sources, but I'd never been able to achieve anything useful, much less portable. Portability in this case was actually crucial since I'd be flying out to Illinois where Edward's workshop was. With most commercially available camera sliders, you either have to buy expensive rail modules in aluminum or carbon fiber that can be assembled to reach your desired length, or shell out requisite baggage fees to ship your gear to the final destination. My goal with this build was to create a slider that you could bring anywhere in the world with a hardware store. I wanted my slider to utilize readily available half-inch EMT conduits for rails. That way, I'd be able to fly across the country and set up a slider with over a meter of usable length for about $5. The slider design was pretty simple. Using a piece of 3/4 inch plywood, I would fabricate a pair of blocks that would clamp EMT conduit 4.5 inches apart. I would use threaded inserts and 1/4-20 bolts to hold the conduit in a set of V-channels. This would enforce the 4.5 inch center-to-center distance that I wanted, even if there were minor variations in tube diameter. Half-inch EMT conduit has a nominal outer diameter of 0.71 inches, so I designed my slider mounts to accommodate up to 3/4 inch rods. After milling the outer profile of these pieces, I drilled holes in them for the threaded inserts. Because I don't have a drill press, I stood up my mounting blocks and used my Shapeoko for the job. The center threaded hole was for mounting on tripods. The platform of my slider was constructed from MDF for maximum precision at minimum cost. I designed a single base plate with shallow pockets to easily locate all of the features I'd glue or screw onto it. Using scraps of plywood, I made triangular blocks so that I could mount skateboard bearings at a 45-degree angle. If I'd had the time to source grooved wheels, I could have used fewer wheels to achieve a self-centering effect. But because I only had 2 weeks to design and manufacture my slider, I went with tried-and-true skateboard bearings. The mounting blocks for the bearings were annoying to manufacture because they required 2 machining operations. I had to work out some sort of repeatable fixturing setup. This meant referencing off known surfaces. I used one triangular block to get a second block's angled face parallel to the XY plane. The edge of my drill press vise was a second surface, and the zeroed height of my end mill was the third reference. I milled out the holes and tapped them. Because skateboard bearings usually have an 8mm bore, they're a perfect fit for 5/16 bolts. I glued these angled blocks to the bottom of my slider platform before bolting on the bearings. And ta-da! I had myself a relatively functional camera slider. With the addition of a ball head mount, I could level an SLR on it and get some nice smooth slider shots. There was a bit of friction because my wheel alignment wasn't perfect, but it was still very usable. But I wasn't done yet. I wanted to motion control my slider so I could get repeatable, precise shots with my setup. The whole point of Edward flying me out to Illinois was so that I could get beautiful, delicious CNC pornography of this Shapeoko 3. By motorizing my slider for ultra-precise movement, I could compensate for my lack of camera skill and creativity. I designed a bracket on which to mount a NEMA 17 stepper motor, and also one just for a GT2 pulley. I also devised a belt clamp for the platform, which was basically just one face of plywood and a fender washer that would sandwich the belt. Using a G-shield and gerbil, I had a pretty simple and easy way to control the speed and position of my camera platform. But wait, there's more! Because I wanted my shots to be perfectly smooth, I was going to take a time-lapse instead of a video. Between each motion increment, I would take a still image with my camera. Taking a picture instead of video also had the added benefit of producing footage with much higher resolution and dynamic range. This required timing each shot to fall when the platform was still. The only way to do that was to trigger my camera in the G-code. Remember that relay board I had from setting up my quiet cut spindle? It happens to work great as a camera trigger too. The physical relay acts just like a button press. I cracked open a cheap remote shutter so I could access Nikon's stupid proprietary accessory port. I ended up writing an overly complicated little script in processing that would take numerical inputs and spit out an NC file. It basically calls M3 and M5 sequentially in between incrementing exposition. At this point, however, I ran out of time. With the hardware and software ready but untested, I packed up my setup and flew out to Shapeoko Central. I was a little nervous about it all, but considering I was heading to Edward's awesomely equipped workshop, I was pretty confident I could MacGyver just about anything on my slider that needed fixing. Luckily, when I got there, all I had to do was tweak some code to get my prototype slider working. Mechanically, it worked like a charm. The smoothness and repeatability of the footage is good enough that I can do shots like this. I'm also able to use the slider manually, so I can quickly grab shots like this, or this, or this. For the future, I have plans to make the entire setup more compact by switching to a smaller NEMA 14 stepper motor and using a single-axis stepper motor controller. Before I sign off, I also want to mention that I'm actually submitting this video to a contest on Festo AG's Facebook page just for the hell of it. I'm not trying to endorse the company in any way, shape, or form, nor am I asking for votes, but there are a couple really interesting projects on the contest page that I thought could be good for inspiration. So from one maker to another, I do recommend checking it out if you have time to kill. That's all I have for today. Thank you all very much for watching, and if you haven't already seen the trailers for the soon-to-be available Shapeoko 3, please stop watching this video immediately and go see it. The machine is a total beast, and I can't wait to see what people make with it when they get their hands on it.